Madam children, this is part 2, chapter number 5, Introduction to Problem Solving. Children, in the last video we have discussed about the algorithm. What is algorithm? Algorithm is set of rules that define how a particular problem can be solved in a finite number of steps is known as algorithm. So in algorithm, finite set of steps are there, each of which may require one or more operation. Okay, so in the previous video we have discussed the characteristic of good algorithm as well as and the components of algorithm. Today we are going to discuss about flowchart and pseudocode. So flowchart and pseudocode both are a method of explaining algorithm. So flowchart is a graphical method and pseudocode is a simple method in which we use just English language for explaining a algorithm. Okay, so let's start with flowchart. So flowchart is a pictorial representation of step-by-step solution of a problem. A flowchart not only pictorially depicts the sequence in which the instructions are carried out in an algorithm but also is used as aid in developing an algorithm. One must be familiar with such important tool used in programming. This section briefly discusses the technique of flowchart. So children, when we make flowchart, we use specific symbols. So these are the symbols which we use while designing a flowchart. So let's discuss about that. So this oval like structure, this we use for the start and stop the flowchart. So we need to start the flowchart and we need to stop the flowchart. After that we are having this rectangular shaped box, little bit slanting lines are there in this. We use this particular shape in while taking the input and while showing the output. After that we are having one big rectangle, specific rectangular shape box that is used for processing. Like suppose if we want to add two numbers, so in this diagonal like box, in this box we take input, and if we apply a plus b, if operation is there, so that particular operation a plus b we are going to do in this rectangular box. So this box basically we use for processing. This box we use at the time of input and output, and this box we use at the time of processing. Like if we want to multiply two number, if we want to divide two numbers, add two numbers, subtract two number, it means some processing is there, so that time we use this particular box. After that one more box, diamond shaped box is there. In this we use comparison, so it means a kind of decision box is there. Like if I'm saying that input two numbers a and b, so we need to check which number is greater. So a is greater than b. If a is greater than b, this particular step will follow. If b is greater than a, this particular step will follow. So this diamond shape symbol basically we use for decision. Okay, then these lines we use to show the flow of control, and then annotation is there. Okay, then connectors are there. So let's make one flow chart with the help of these symbols. After that you are able to understand how exactly we can make the flow chart. Okay, so writing, before we move forward for making a flow chart, to write an algorithm, such a language should be used that is close enough to the programming language in which programs are to be written, so that a hand translation is relatively easy to accomplish. Thus we have chosen a language for algorithm that resembles our programming language Python. So in that many things are there we are going to discuss. So first is assignment. Now suppose we have done the programming based, Python based programming. So let's quickly revise. If I'm saying that a equal to 5, what is the meaning of that in Python or in other language? It means that a is assigned by 5 value. It means a is having 5 value, but we also say that a is assigned by 5. A is assigned by 5. So when this particular thing, if we represent in a form of flow chart, we use this arrow basically. So if I'm writing a arrow 10, one of the same thing, it means a is assigned by the 10 value. Okay, now sequence, the step of algorithm are executed in the sequence of top to bottom. So when we design a flow chart, we have to be take care about the sequence. So it should be top to bottom. Like if we want to add two numbers, so we have to start the algorithm, then we need two inputs like this. In this box we take input, then processing is there, then we need to close that particular flow chart. So it means top to bottom one sequence should be there, one after the another, so the step must be listed in a correct order. Now after that we are having selection and conditional statement. A conditional statement is an algorithm takes place. Now we have already discussed about the conditional statement, as well as we have learned about three statements: selection statement, we have learned about the sequence statement, we have learned about the repetition statement. So in the sequence we have to maintain the sequence order, like we need a two number, then we have to add that, then we have to show the output. In the selection statement we are having if and else if. So few conditions are there in the conditional statement. And in repetition, in looping, we are having two types: one is for, another is while. So when we are using these for and while, we use when we want to repeat few steps. Like suppose I want to print first 10 natural number, so loop should be repeat 10 times, children. So that time we choose for and while. Both are similar but little bit different. So in chapter number 9 everything is going to be clear to you, when we are using for, when we are using while. So here we are talking about here we are talking about the statement. The first is sequence, in which we have to maintain the order. Then we are having selection and conditional statement, there we have to check the condition. Okay, then repetition, looping are there. So let's see how we exactly use looping. So start the program, then we are having this, then sequence, we have to check that sequence. If that particular condition is true, it means yes, we have to move in this direction. If particular condition is false, we have to move in the lower direction and repeat that particular task. So in this way basically these statements work. Now let's move to the next part. Now next is the while. These are the pictures from your book only. So again I'm repeating, while and for both are similar, but difference in the giving the syntax of that particular format. So represent the set of statement to be repeated. While iteration statement test the condition before entering into the loop. Thus if the condition is false even before entering in the loop, the while loop will never get executed. So for loop and while loop there is a difference. So while loop first check the condition. If that particular condition is true, then only you are able to enter the particular set of instruction. If it is false, you are not able to enter in that particular condition. Okay, now let's discuss few questions. Draw a flow chart to add two numbers along with the algorithm in simple English. Now you have to make the flow chart and you have to make the algorithm as well as. So first discuss algorithm. So algorithm is few set of instruction in a simple English. Few sentences are there, you need to give the instruction only. Suppose start, then get two numbers n1 and n2. Simple English is there, n1 plus n2. Now if we are adding n1 plus n2, if I am saying that both variables sum is going to be stored inside the s variable, so instead of this equal to, we are going to use this arrow sign. So one of the same thing, then print the result s, then stop the algorithm. Okay, simple to write. Now let's see how to make the flowchart. See, you have to start the algorithm, then read n1. It means you are taking input first, you are taking another input second, then n1 plus n2. It means you are doing processing here, so you have to use this particular rectangular big box, and after that it is going to store at s. Here you can use equal to sign, nothing to worry whether you use this or equal to. You can use both of the thing when we are designing the flow chart. Okay, now this n1 plus n2 is stored inside the s variable. It means we have to print s. So again output you have to show, so you have to use this particular dialog box. So again I am repeating this particular shaped symbol we use for input and output. So here we are taking input and here we are giving the output. Getting my point? Now let's see another question. Draw a flowchart to find the area and parameter of rectangle along with the algorithm in simple English. And L stand for length and B stand for breadth of the rectangle, area of the rectangle, parameter of rectangle. Okay, so we know that what is the area of rectangle? L into breadth. What is the parameter of rectangle? 2 into L plus B. Okay, so start. Then input, what we need input, we need length and breadth for that. So we are saying that length is going to represent as L and breadth is going to represent as B. Okay, then we need to find out the area. So area is going to store inside this area word, and parameter is going to store inside the parameter word. Then print area and parameter. I hope you are able to understand exactly how we are writing the algorithm. Then start, input ln b, then area equal to ln b, processing is there, again processing is there, then you have to print the area and parameter. So just remember the correct symbol, which kind of symbol you need to use while doing input, while doing output, while processing. You can easily make the flow chart. Okay, so with this let's move to the next question. Now let's see the next question. Now draw a flow chart to convert temperature from Celsius to Fahrenheit along with the algorithm. Now you can have a similar question, like question can be asked to change Celsius to Fahrenheit temperature or Fahrenheit to Celsius temperature. So both formulas are there inside. See, let me zoom that. So both formulas are here. If you have to convert Fahrenheit to Celsius, so this formula you have to use. If you want to convert Celsius to Fahrenheit, this formula you can use. So simply for that you need a start, then at the end you need to stop. So input temperature in Celsius, because question wants to convert Celsius to Fahrenheit, so you need a temperature in Celsius, then use the formula, then print temperature in Fahrenheit. So in the with the help of 4 or 5 steps you can complete the algorithm. So again, start, input a Celsius temperature, then convert it, then print f, stop. Okay, now draw a flowchart to determine the larger of two numbers along with the algorithm in the simple English. So again, this question I have already explained you that if you are having two numbers and you have to compare which one is larger, so you have to compare with this sign only. So start, get two numbers a and b. If a is greater than b, then a, print a, else print b. One of the simpler question. Okay, so again let's see the flow chart. So start, read ab means you need a and b input. If a is greater than b, you have to move in this direction, print a, and if this condition is false, no, so you have to print b. So in the both case you meet at the stop button. Okay, now let's move to the next question. Now draw a flowchart to calculate 2 की power 4. So I hope after this you all are able to solve such kind of question. Now let's move to the next topic, that is pseudocode. Pseudocode basically a kind of informal language that helps programmer describe set steps of programs solution without using any programming language syntax. So in this we don't have any kind of format to write something. Pseudocode is a text based detail design tool. A pseudocode creates an outline or a rough draft of a program that gives an idea how the algorithm works and how the control flows from one step to another. For example, see, simple language is used in this. Okay, so if student marks is greater than or equal to 50, if this particular condition is true, display passed, else display failed. So see, very simple language with the help of which we can simply find out a solution of any problem. So let's discuss what are the advantages and disadvantages of pseudocode. So pseudocode is very useful and helpful tool in algorithm development. It offers many advantages and it has some disadvantages too. So pseudocode advantage, it uses a language similar to everyday English that is easy to understand. It highlights the sequence of instruction. The structure of algorithm is clearly visible through pseudocode selection and repetition blocks. Pseudocode can be easily modified without worrying about the dependency. Pseudocode disadvantage, it is in pseudocode we don't have any visual tool. Like in flowchart we are having a visual tool, but in pseudocode we don't have any visual tool. Okay, so since there is no accepted standard for pseudocode, so it varies from programmer to programmer. So there we don't have any kind of format, so you have to take care about any format. So you can write anyway, in which pattern you want to write, that is your wish. So it depend on programmer how you are actually thinking to design a pseudocode. So it can only be tested on paper. There is no program available to test it. So in this we have to check on paper only. Writing a code on a paper, just you can check and debug the errors in that, because we don't have any particular program to solve the errors whatever present in your pseudocode. So it is an informal representation of an algorithm. Okay, so let's move to the next question. So let's take one example of write a pseudocode that convert from Fahrenheit to Celsius or from Celsius to Fahrenheit. So both formulas you are having, you just need to write the pseudocode depending on the user's choice. So x is a variable input, press 1 to convert from Fahrenheit to Celsius, please press 2 to convert from Celsius to Fahrenheit. So input asks what number. So y is going to store that number whatever you are going to enter. If 1 is pressed, so this particular set of instruction follow. Else if 2 is pressed, this particular condition statement going to be follow. Else print enter either 1 or 2. If you are pressing another number, so computer will ask for another, computer will force you to enter only 1 or 2, because you are having only two options. One option to convert from Fahrenheit to Celsius, second option from Celsius to Fahrenheit. Okay, now let's move to the next question. Next question is write a pseudocode that asks how many numbers, say n, then print all those numbers after n have been entered. So if you are n is 5, so it will start from 1 to 5 in this way. So just a kind of language, just kind of pseudocode you can easily write. Okay, now another topic is verifying an algorithm. See children, verification of algorithm means to ensure that algorithm is working as intended. For example, if you have written a program to add two numbers, but the algorithm is giving the product of two numbers, in this case algorithm is not working as intended. So how do you verify an algorithm? You are right, we should test it with a simple input for which we know the outputs. Like if we want to add two numbers, so 2 plus 4 is always 6. If by chance that algorithm is based on product, so 2 into 4 you will definitely get 8. So if you can check by giving an input, only those input you give whose output you know. So in this way you can easily verify your algorithm. Okay, this is really helpful, but for larger algorithm we may want to verify the intermediate result too of various steps of algorithm, and for such requirement a useful mechanism we need for verifying our algorithm. For that we have a dry run. Okay, so let's talk about what is dry run actually. So a dry run is a process of programmer manually working through their code to trace the value of variables. There is no software involved in this process. Okay, so characteristic of dry run. It is carried out during the design, implementation, testing, and maintenance. It is used to identify the logic error in a code. It cannot find execution error in a code. Okay, so how you can do dry run in that? So you can simply make such kind of table if you are able to see on your screen. So for numbers 1 to 3, it means it will start from 1 and at 2 and at 3, sorry. So 1 into 2 is 2. So every step, whatever well variable is having a value, that is going to show in this way. So this is called a dry run method, in which we use pen or paper to check the possible answer. Okay, so let's have a look on this. Dry run the code given below. So user input going to store at num, count is equal to 0, while user input is less than 500, then num equal to num into 2. Suppose your user input is 16, count is 0. Okay, so 16 is lesser than 500, condition is true. So this condition is true. Then 16 into 2 is 32. So again next is 32. Then count is 1. Again 32 is less than 52. So in this way all possible value is going to be shown in that particular table. Okay, so this is the method of verify the algorithm. Now, comparing algorithm. To solve a problem, many times, in fact mostly multiple solutions are available. In other words, you may have multiple algorithms which working correctly and producing the correct desired result. In such a case, which algorithm should we choose for coding? In order to decide which algorithm to choose over another, their efficiency will be deciding factor. So major factors that govern the efficiency of algorithm are time it takes to find the solution and the resources which are consumed in the process. For instance, while buying a car, would you choose a car from available choice? Yup, you are absolutely right. You might consider both the speed and the fuel consumption, the factor that matters the most to you. So that is a better way to choose an algorithm. Okay, so um, similarly for algorithm, two deciding factors are space wise efficiency and time wise efficiency. Space wise efficiency, how much amount space algorithm will take up before it terminate. For this we consider the amount of data the algorithm uses while running. Time wise efficiency, how much time the algorithm takes to complete. So this factor is dependent on so many issues like RAM available, programming language chosen, the hardware platform, and many others. So we have discussed about each and everything in this chapter. This is a very small chapter, children. Just go through it, how actually we can solve the problem and what factors are there for while solving a problem. So that's it with this chapter. This chapter is finished now. I hope you all are able to understand. Thank you so much for attending this class. Sai Ram.